Welcome back, boys. Good news is this is our last chapter. It is chapter 9. It involves solving quadratic equations. So our last chapter involved quadratic functions, which mean the same thing. So the good news about this is I'm going to show you 4 different ways to solve these quadratic equations. Now, yes, you have to solve them a certain way now, but when we're done with the chapter, and I tell you that you can solve them in any way, then you get to pick any way you would like, okay? So here is the first lesson. So the first lesson is graphing. I would say not one of the best ways to solve these equations, but you still have to learn it. The next one is using square roots. So you do have to have your, remember that sheet I gave you in class? You still have to have that memorized. You have to complete the square, which is by far the worst way to solve these, being completely honest, but you do have to know how to do it for, I believe it's calculus. So yes, you have to solve them by completing the square, but then after that, you don't have to do it any other time. And then the best method ever is using this quadratic formula, which if you took Algebra 1 already, you should know. And it is the best method. It gets you the right answer every single time. So we're going to start with graphing, okay? So you're going to solve these equations by graphing, and then we're going to actually find the zeros of these graphs. So we do have some vocab. So a quadratic equation is a nonlinear equation that can be written in standard form, which you can see, and obviously this is nothing new to you. The solutions where the graph crosses or touches the x-axis are called the x-intercepts, also a word from before. They are also referred to as the roots or zeros of the graph, okay? So all 3 of those words essentially mean the same thing. It's just if you're talking about the graph or you're talking about the equation. But again, they're all synonyms of each other. So let's go back to chapter 6, which obviously none of you will remember. It is our factoring chapter. So when I gave you this equation, okay, it was a quadratic equation. If I cover up the equal 0, you were to find factors of 3 that would add or subtract to give you the 2. Okay, this was a diamond X puzzle, if you remember those. So first thing we need to do is make sure it's set equal to 0, and we're going to get 2 answers because the exponent is 2, okay? And there were my factors. So factors of 3 that sum to give me 2 would be 1 and 3, and the 1 would be negative. And if you were to FOIL that, you would get the same problem. But now I need to actually give myself x equals. So you take each of those, you set them equal to 0. And yes, you have done this before. And you would subtract your 3. You would get x equals negative 3. You would add 1. And you would get x equals 1. So these are your solutions. Okay, and they would make your equation true. But like I said earlier, they are also called the zeros, roots, or x-intercepts of the graph of that equation, okay? So you don't actually need to factor these. I'm just trying to show you that everything we've done in the past is finally going to catch up to us. All right, so there are 3 graphs in front of you, and they're all quadratics. They're all parabolas, and they're all opening up. But if you notice a difference in the first one, this graph does not touch my x-axis. And this was a question on your review from last week. Some of you got it wrong. This is my x-axis. Nowhere is my graph touching. So, well, I'm kind of going to give you the answers, but there is no solution. So since there's no x-intercepts, no solution. And this parabola, it touches it once, so there's 1 answer. And then obviously this parabola touches it twice. So these are the only 3 possible solutions you could get. No solution, just 1 or 2. Okay? And by graphing them, you could see fairly quickly how many answers you're going to have. All right, so pretty much you need to, these are the steps. is make sure you write the equation in standard form. And the most important thing would be to make sure it equals to 0. So if there were other numbers on the other side, you would have to move them over. Then we're going to graph, and then we'll find our x-intercepts. All right, so here's our quadratic equation. We do not have to move anything from the other side. It's already in the correct form. Now, the easiest way to do this, and this example, you're going to get 2 real solutions. Okay, now obviously this is a 2, so that's how many you can get. But based on the previous picture, you could get 2, 1, or none. Okay, so we're going to find our vertex. So the first thing we should do is do A equals 2, B equals -8, and C equals 6. You should remember this from the end of last chapter. So to find our vertex, it was x equals -b over 2a. And then when we fill those numbers in, you would get negative, and then you get a -8 divided by 2 times 2. So it'd be 8 divided by 4, so it looks like x equals 2. So now we're going to plug back in. So we're going to take our 2, plug it in for x, here and here. So 2 times, we got 2 squared minus 8 times 2 plus 6 equals. Now if you follow PEMDAS, you would get 2 times 4 minus, what was that, 16 plus 6. Keep working left to right, and it looks like you would get a -2. So our vertex, like I said, is the most important point of any parabola, is 2, -2. So now we're going to have this table of values, and don't worry, I'm going to fill in the x's for you just because it's just easier right now. So all you have to do is find the y values. So if you look right here, x of 2, well, the y is obviously -2. Now you should know how to get the rest of these, but I can do the 0 for you. So if you plug in 0, you would get, obviously that would be 0, that would be 0, so you're going to get a 6. Okay, and I'll do the rest. You would get 0, and then 0, and then 6. Okay, so these are all of our points. Oh, I'll go back and let you see these. So these are what you're going to be graphing. All right. So that's the same table you just saw. So let's graph those. All right, there we go. Let's draw our curve. There's our open face parabola. Whoops, did not mean to do that. And then the very last thing will be to find our x-intercepts, which would be here and here. So this does have 2 solutions. That x value is 1, and that x value is 3. So it looks like the solutions are x equals 1 and x equals 3. So it's very, very easy. You have your graph, you look at it, you give me your x-intercepts, you write me the solutions are blank and blank, and you're done. All right, so let's do another one. So this one's only going to have 1 real solution. So first thing is we have to find our vertex, but see this needs to go on the other side. It has to be in standard form. So x squared minus 8x plus 16 equals 0. So a equals 1, b equals -8, and c equals 16. So if we do our vertex, we're going to do -b over 2a. So it's again going to be a negative, and then a -8 over 2 times 1. Negatives cancel. 8 divided by 2 is 4. Now we're going to plug back in, and we would get 4 squared minus 8 times 4 plus 16. Follow PEMDAS. 16 minus 32 plus 16 equals 0. So our vertex is 4, 0. So that's, again, the most important point. Now we have our table of values. So when x was 4, if you see right here, our y was 0. So let's plug in the rest of these. So let's try 2. So I'll do it over here. So we got 2 squared. And then we got 8 times 2 plus 16. We got 4 minus 16 plus 16. Follow PEMDAS, and it looks like you get a 4. So there's your 4. And now, again, I'll just do the rest for you. This is a 1. That's a 1. That's a 4. So here are points that we're going to plug in. Same chart. Plot your points. Make your curve. But if you notice, it's only crossing the x-axis at one spot. So our x-intercept is x equals 4. It's technically like a double root because it's there, it's showing you 1, but remember how the exponent of 2, meaning there are 2 answers? Well, both answers would be x equals 4. So the solution is x equals 4. So our last one is going to be one that has no real solution. So that's going to be like the floating parabola where it doesn't cross your x-axis. So standard form is already good. So we got a1, b equals 2, c equals 4. Let's find our vertex. So -2 over 2 times 1. So it looks like -1 is our vertex. And we're going to plug back in and get -1 squared, and then 2 times -1 plus 4. PEMDAS. And I do believe you'll get 3. So vertex is -1, 3. Table of values. Oh, look, there's my x -1. So that is 3. Now I'm going to already plug in the rest of these points for you. So you would get 7, 4, obviously 4, and then 7. Okay. Same table of values. Graph, draw your line. Notice it is floating. Find x-intercepts. There is no solution. Doesn't touch. Okay? Doesn't touch x-axis. So that is why it is a no solution. All right, now the last part, which requires no work at all, is me giving you a graph and you finding the zeros. So you're finding me the answers. You're finding me the x-intercepts. Okay, so recall that the 0 of a function is the x-intercept of the graph of the function. So let's look at this. We have point right here. We have a point right here and a point right here. Now, obviously, this is not a parabola. This is actually a cubic function. So it's an x cubed. That's what makes it cubic. But don't worry about that. So what I need you to do is basically tell me what these x values are of these red circles. So it looks like the x-intercepts were x equals -1, x equals 2, and x equals 3. So the sentence that you need to write are, the zeros are -1, 2, and 3. Extremely easy. No work. The only work would be to put the dots on the graph. All right, let's do one more. So let's put crosses here, crosses there. Remember, it's only the x-axis. So right here is not an answer. Okay? Not an answer. So let's see here. So we got x equals -3 and x equals 1. So the zeros are -3 and 1. All right, boys, this should have been easy. So I expect to see your graphs, your work, and your zeros. And your assignment is a worksheet. I will see you very soon.